So in this video, I'm going to talk about some special cases with absolute value inequalities, like, oh, wow, that's so special. Okay, so here are the special cases. All right, so, looking at this, I'm assuming you know some things about absolute value inequalities at this point if you're watching this video. And okay, so here's the deal. For this first one, so the first thing that I need to do is I need to subtract the 7, right? And then I've got the absolute value of 2x plus 3 is now less than negative 3. Okay, so I actually want to compare these cases A and B together. That's why I wrote both examples here. So I want you just to notice. So this one is talking about an absolute value being less than a negative number. This is talking about an absolute value being greater than a negative number. Okay, so you honestly have to think through what it means to be absolute value. So here's the thing about absolute value. All absolute values are going to be greater than or equal to 0, right? They're always positive, or they could be 0. And you have to now think about, what does this really mean? So in this context, this is really saying, if we back out and we don't go into that computer mode of oh, I've got to set up this thing, right? But instead of I just think about, okay, what is this actually saying? It's got a negative. This is saying that some absolute value is less than negative 3. If this is what I know about absolute value, that it always has to be greater than or equal to 0, when is this true? This is never true, right? Absolute value cannot be less than negative 3. It can't be less than a negative number because it has to always be greater than or equal to 0. So this is never going to happen. So this is no solution, or our favorite, the empty set. Okay, but now compare that to this other one. And so the way I would think about this if I were you is to not be in this computer mode of oh, I got to set it up or whatever. And also don't just be oh, it's negative, so no solution. You have to stop and think for a second, all right? So if I think about this second one, so now this is saying this absolute value is greater than a negative number. Okay, so again, think about this in the context of what we know about absolute value. All absolute value is greater than or equal to 0. So when will this be greater than a negative number? This is always true, right? Because absolute value has to always be greater than or equal to 0, so therefore it's always going to be greater than a negative number. So this is always true. So the solution set here goes from negative infinity to infinity. So I want you to really understand this, maybe even write an explanation to yourself of how you're going to remember this. Write this out in plain language that you would remember. Because the thing is, I notice a lot of times when students see these examples, they try to just remember, oh, it's negative, so then it's just never going to be true. And that's not how it works with inequalities. So you're actually going to have to think of, how does this make sense to you, so that if you see it out in the wild, that you know how to think through it. Okay. So now I want to look at 3 more examples and comparing everything to 0. So once again, I just want to restate, all absolute values are always going to be greater than or equal to 0. Okay, so I actually think this is a great time for you to pause and just to test your intuition and to really think about, what does this mean? So pause here, and I want you to write down, the worst that happens is you get it wrong, right? Which is not a big deal. Nobody's going to know. But write down what you think makes sense. Really think about this for a second, and then hit play when you think you've got it. Okay, so for this first one, this is an absolute value, and it says, when is it greater than or equal to 0? This is literally the definition of absolute value, right? This is actually always going to be true because this is the fact of all absolute value. So this is always true because it literally just matches up with the definition. So I don't have to do any work for this one. And then, so for this second one, so when is this less than 0? Well, absolute value always has to be greater than or equal to 0. So anything less than 0 will be negative, right? If 0 is not included in this, so this will imply that this will end up being something negative. So again, this is also never true. Empty set. Boom. Okay. Okay, now E, I think, is the most interesting case. When is this less than or equal to 0? So we know that the less than case is never true, but there's now the or equal to. Is it possible for an absolute value to equal 0? Yes, we have it has to be greater than or equal to 0. So it's possible for it to be equal to 0. So I always think this is such a weird case with an inequality, because usually most inequalities will not use an equal sign. When you start with an inequality, you end with an inequality. But what's interesting about this is, so this is never true that it's going to be less than 0, but it's totally possible that this could equal 0. So what's interesting is that this is an example of an inequality where I don't need the inequality sign to figure this out. I actually need to just take the equality part of this, the less than or equal to. I need to just take out the equal to. So I can solve this, and let's see, actually I'll get rid of all this. So I have 6x equals -2, and then x equals -1/3. So this is super strange. This is like probably one of the only cases I can think of where this works out like this. The answer to this is an equals. So this is the answer. Strange. Any other absolute value problem that you deal with, you always have greater than, less than, you have inequality signs in it. But because this is a special case, this has one solution, x equals -1/3. Okay, so if you're looking for more instruction or examples, I do have other videos on that, so be sure to check those out. If you found this helpful, consider hitting the like button, and I will talk to you guys in another video.